In today's guerrilla warfare, especially as it's practiced in the Orient, one of the most challenging and dangerous problems which confronts our combat forces is the enemy's use of earthen tunnels. Tunnels and caves were used by the Japanese in World War II and by the Koreans during the conflict which followed. Once the line of battle had moved past them and the area in which they existed was secured by our troops, these subterranean fortifications were permanently neutralized as a part of the area consolidation. Today, however, a different type of warfare is being waged. Rarely are areas held long enough to be thoroughly cleaned out. Instead, the major actions of our combat troops consist of search and destroy operations. Intensive drives through enemy territory with the primary objective of finding and destroying his forces and then moving on. Seldom is the occupation of terrain for extended periods an objective in itself. And in these situations, the enemy's use of earthen tunnels becomes increasingly serious. He can hide in them until our troops pass, then emerge and attack from the rear. In them, he can store supplies for future operations in the area. If the enemy leaves his tunnels deserted during a sweep operation, he will find shelter and operational facilities in them when he returns. And if they are intact, he can resume his guerrilla activities almost as though no interruption had taken place. Thus, it is obvious that to effectively strike the enemy and destroy his ability to wage war in guerrilla situations, his tunnel shelters must be demolished or denied him as they are encountered. This is a relatively new but important military concept, for tunnel use is included in the doctrine of various armed forces, particularly in the Orient. In the future, this doctrine may well be applied not only to guerrilla warfare, but to any type of conflict anywhere in the world. Therefore, an understanding of earthen tunnels and the means of destroying or neutralizing them is essential to today's soldier. Earthen tunnels may be dug or utilized in military operations wherever the tactical situation warrants, although they are practical only where large civilian labor forces are available for their construction. Earthen tunnels consist of two general types. First, there are those called expedient tunnels. They are relatively simple in construction and varying in length from approximately 20 to several hundred feet. This type includes ambush, safe hide, riverbank, or escape tunnels. Such tunnels are not intended to provide permanent protection or shelter for their occupants. The second type is made up of several levels of tunnels called a complex, which is a series of rooms interconnected by many smaller tunnels. A complex may extend up to 30 feet in depth below the Earth's surface and extend over large areas. They have carefully camouflaged entrances to facilitate evasion and escape. In complexes such as these, personnel may be hidden, housed, trained, and hospitalized. A headquarters may be set up and maintained, and supplies stored. Many of these complexes date back to World War II, and since have been enlarged and reinforced to provide maximum protection against air and artillery strikes. Such huge complexes are generally found away from populated centers. They are the most difficult to demolish, but can be destroyed if time, supplies, equipment, and personnel are available. When a tunnel entrance is discovered, the area around it must be examined for booby traps or mines. These are generally used by the enemy for protection or warning, and until this check has been completed, the tunnel should not be entered. Before entering a tunnel, recon personnel must have the equipment they need to do the job. A powerful flashlight in good condition and with fresh batteries, and a probe, such as a bayonet, is a must. So is a protective mask and a hand weapon. With the entrance area cleared, the next step is to perform a thorough reconnaissance of the tunnel to determine how recently it has been used and if enemy personnel are present. This reconnaissance is essential. Powerful weapons should be avoided, for if fired in a tunnel, their intense sound blast can cause deafness lasting as long as 30 minutes. And a tunnel and flushing team need all their senses in full working order at all times. When a tunnel entrance shaft goes vertically into the ground, as here, the first man to enter it should be slowly lowered into the shaft head first to permit him to thoroughly check the entrance walls and floor for booby traps or mines as he moves into the tunnel. When the shaft is over 8 feet deep, the point man should be secured with a rope so that he can be quickly pulled to safety in case of emergency. As the point man arrives in the tunnel, he carefully checks to be certain that no enemy is awaiting him near the entrance. If the area is clear, he works his way into the tunnel and awaits his backup man. As they enter the tunnel, both men must be alert for any odor which suggests the presence of chemical agents. And if such odors are detected, protective masks must be donned before continuing farther. When both men are in the tunnel, they begin their reconnaissance, cautiously and carefully. Initial reconnaissance is limited to the first 10 feet of a tunnel. If it continues beyond 10 feet, the recon team should return to the entrance to pick up CS grenades and communication equipment. Then they resume the reconnaissance of the entire complex. In this demonstration, this action is omitted. During tunnel reconnaissance, always assume that the enemy is somewhere in the tunnel. He probably is. And always assume that the tunnel is booby-trapped, particularly in the more elaborate complexes where the enemy has had ample time to install such traps. Carefully examine all surfaces of the tunnel, floor, walls, and ceiling, for booby traps or mines, as well as for false walls or hidden passageways. Never undertake a tunnel reconnaissance with less than 2 men on the recon team, and stay together within the tunnel complex at all times. Observe extreme caution to protect yourself against the enemy who may lie in wait just beyond. During a tunnel reconnaissance, each man has a definite job to do. The point man is concerned with booby traps and mines, as well as the possibility of enemy contact. The backup man is alert for information of intelligence value. He also notes details of the tunnel construction and layout, and estimates the depth of soil which lies over the tunnel complex throughout its entire length. This soil is called overburden. When the tunnel has been thoroughly explored and its extent, size, depth, and contents have been determined, this information is carefully and completely noted. Then the precise location of the tunnel is established. This information must then be reported through channels to the tactical commander. On the basis of factors which are inherent in the overall combat situation, the commander will decide whether the tunnel should be destroyed, otherwise denied to the enemy, or bypassed. The extent of desired demolition or denial may be left up to the unit commander. The factors which will determine the type of tunnel denial to be undertaken during combat operations will relate to the tactical situation at the time. First, how much time is available for destruction? How much time will the primary mission allow for such work? Second, how much time is necessary for total or partial destruction? These must be weighed against each other. Third, what equipment and personnel are required for the different types of denial in relation to the tunnel in question? Are such personnel and equipment available? Finally, how important is the tunnel or complex to the enemy? How valuable will it be on his return to the area? These are the things which must be considered in determining the type of tunnel destruction or denial appropriate to an individual situation. The methods of tunnel denial which may be employed in combat situations can be divided into three general categories. First, immediate denial, which can be completed in minutes with equipment normally at hand. Second, partial destruction, which also can be accomplished within relatively brief periods of time with available equipment. And finally, total destruction, which requires trained troops and equipment not normally carried into combat areas. The purpose of immediate denial tunnel action is to flush the enemy out of his hiding place and deny him its use for a decisive period of time. The results obtained are immediate, although of relatively brief duration. To drive the enemy from the tunnel, CS is used in solution or powder form. When CS powder is used, the material is liberally sprinkled into the entrance. The tunnel is then sealed as tightly as possible, forcing the CS fumes to spread back into the underground passageways and drive the enemy out through other exits, since normally they have no protective masks available. The M106 chemical dispenser can be carried by one man and may be used to blow chemicals into a tunnel. After checking the area for enemy personnel and booby traps, a poncho or other suitable cover is placed over the tunnel entrance. The discharge hose from the dispenser is inserted through the cover, ensuring that a tight seal is maintained around the hose. The outer edge of the poncho is sealed to prevent the chemical from escaping. After all openings are sealed, the engine is started. The fan then forces the chemical throughout the tunnel. CS may also be introduced into tunnels by using CS grenades. As in all such denial efforts, the tunnel entrance should be tightly covered to prevent the escape of the CS fumes and force them back into the passageways. Partial destruction involves damaging the tunnel so that it will be immediately useless to the enemy and reusable only after considerable repair. Generally, concussion or fragmentation grenades are tossed into the tunnel or shaft entrance to collapse it. The destructive effect of these grenades will depend on the amount of overburden at the point of explosion. If the overburden is relatively light, the grenades may completely collapse the tunnel entrance or shaft and seal off the entryway. Even if complete collapse is not obtained, grenades will usually dislodge enough earth to effectively block the entrance. All entrances must be treated in this way to completely neutralize the tunnel complex. Conventional military explosives such as dynamite, TNT, or C4 can also be used in partial tunnel destruction. C4 is normally available under combat conditions in M37 demolition charge assembly kits. Using the blasting cap crimpers contained in the demolition kit, prepare 2 of the blocks to receive the demolition priming assembly boosters. Two of these assemblies are contained in each kit. They consist of 5-foot lengths of detonating cord with a priming adapter and booster attached to each end. Place the boosters into 2 of the 8 blocks. To complete the firing chain, attach an electric cap with firing wire or a non-electric cap with a length of time fuse to the demolition kit. We will use a non-electric firing assembly. Cut a piece of time fuse of sufficient length to allow personnel to move back to a safe area. Place the non-electric cap onto the time fuse. Crimp it using the blasting cap crimpers. Attach the blasting cap to the 5-foot length of detonating cord. Finally, attach the fuse lighter to the time fuse. When the explosive assembly has been completed, fire intensely into the tunnel entrance to drive back any enemy who may be waiting inside. Place the charge as deeply in the entrance as possible. Then ignite the fuse and quickly withdraw to a sheltered position a safe distance from the entrance. While awaiting results, keep the entrance covered for enemy personnel. These are the primary ways in which partial tunnel destruction is accomplished. In addition, unit commanders may call in artillery or high-angle weapons to demolish tunnel entrances. The total destruction of a tunnel is a job which should be handled only by specially trained troops, using equipment not normally carried in forward areas during combat operations. Thus, it obviously requires more time than is necessary for the partial destruction just demonstrated. Once total destruction has been directed, the first step is to have another thorough reconnaissance of the complex made by the specially trained personnel assigned to the demolition. These men will make certain that the tunnels are clear, that no enemy personnel or booby traps have been overlooked in the earlier exploration. They will precisely map the complex and carefully estimate the overburden throughout the entire system, making special allowances in their estimates where multi-level tunnels are involved. Based on the findings of this reconnaissance, the amount of explosive can be calculated and charge placement can be determined. Calculation is based on rule of thumb, which is developed through extensive experimentation and experience within the area of operation. It requires consideration of two factors: the amount of overburden and tunnel length. The rule of thumb requires that for overburden up to 10 feet, use 2 pounds of explosive per foot of tunnel length. Increase the amount of explosive 2 pounds for each additional 10 feet of overburden. The charges should be ground placed at turns or corners of the tunnel, as well as at strong points. A type of explosive should be used which can be primed with detonating cord. All tunnel entrances which can be discovered should be blocked with sandbags, and the shaft should be filled with well-tamped dirt. This is particularly important, for the more the explosive force is confined to the tunnel, the more destructive and effective it will be. In tunnel destruction, explosives should be primed with det cord and then electric or non-electric means used to initiate the action. However, electric means is best because it gives you full control of the firing at all times. In certain situations, Bangalore torpedoes, shaped charges, cratering charges, or similar special purpose charges may be used in total tunnel destruction. In its continuing search for more effective ways of destroying large enemy tunnels and complexes, the Army has developed this XM-242 liquid explosive demolition kit for use with the powerful liquid explosive nitromethane. Each kit contains the equipment required to destroy a tunnel 500 feet long with an overburden of 10 feet. The kits can be combined to destroy larger tunnel systems having up to 30 feet of overburden. Each kit includes a portable gasoline engine-driven air compressor, 2 55-gallon drums of liquid explosive nitromethane, enough hoses to connect to the compressor, and 55-gallon drums. A pressure relief valve designed to vent off internal line pressure which exceeds 15 psi. A valve flow control regulates the flow of explosive, and a monitor box that indicates when drums are empty. The monitor box is connected to a sensor attached to the hose inside the drum by using 500 feet of cable. The kit also contains an arrestor that provides a safety device to prevent propagation of the detonation back to the drums and pumping equipment. Tools and accessories for assembly. And finally, a drag pack containing 500 feet of lightweight, lay-flat plastic tubing. After the hose and generator are connected to the drums, this plastic tubing is paid out and must be tied off with a figure-8 knot. Overhand knots will not hold. The wire for the monitor and firing wire are paid out. The monitor is connected to the monitor wire. At the tunnel entrance, explosive is placed around tubing and primed with 2 blasting caps. blasting cap wire is attached to the firing wire. The compressor is started. The safety valve is closed to start pumping the nitromethane into the plastic tubing. Be sure that nitromethane is flowing through the flow sensor module into the plastic tubing. Then move back to the firing point. At the firing site, the firing wires are attached to the blasting machine. The monitor is checked until one of the lights goes out. Then the charge is fired. These, then, are the general principles of neutralizing or destroying enemy earthen tunnels in combat. Such installation should always be treated with respect and should be entered only with the utmost care and the proper equipment. Earthen tunnels discovered in combat situations should be thoroughly explored to determine their size, extent, and significance. Then the findings of the recon team, together with the tunnel's precise location, must be reported through channels to the overall tactical commander. He will determine and direct the appropriate disposition of the installation. For immediate denial, CS in various forms may be used by combat personnel. For this to be effective, all entrances to the tunnel must be tightly contained to keep the agent from escaping. Combat personnel can accomplish partial destruction of tunnels by collapsing entrances with concussion or fragmentation grenades, as well as available conventional military explosives. Combat troops can perform denial or partial tunnel destruction as a part of their normal mission. Total destruction of a tunnel requires trained personnel with specialized equipment. Whichever type of tunnel destruction is dictated by the tactical situation, it should be performed carefully and completely. Only in this way can the enemy's vital tunnels and complexes be denied him.